So on today's agenda is we're gonna refactor out the interest crediting stuff to a strategy. And so yes, I realize this is like um, the fourth episode where I'm working on interest credit, but I think it's kind of cool because actually how complex the behavior that we want is. Where we left it after episode 11 was we found that after we had implemented the proper interest crediting stuff, we found that in our uh, in our deposit test, if it turned out that there was time that passed between depositing the money and checking the balance, that we could get interest rate being credited here, and we actually don't want that. So to make it more clear what was happening, um, let's let's show this. So here, the scenario that I'm talking about is where we create the account, and we create it on February 27th, and there was a deposit on the previous December 27th. So basically 2 months went by. When we ask for the balance, remember from last time, what it does is it calculates on the fly any catch-up interest rate charges, interest rate credits that it needs to make up for. And normally that's fine, right? So for example, this is basically saying that there was a deposit here. This is basically today's date. And so therefore, since we consider the account being opened on the first transaction date, so December 27th, we'd expect it to calculate interest for January 1st of 2019 and February 1st of 2019. But this test is just the deposit test. And so we find that what happens sometimes is as you add on more functionality to your objects, you may find that they start getting coupled with other functionality. And so if we just take a look at account and we just look at sort of how complex it's become, um, and my sort of bar for complexities is probably quite a bit lower than most folks, because you might think, oh, that's not that much, right? There's only, 150 lines of code in here. But what I look for is, what I'm looking at here is cohesion. And so we have account, and we have basically doing interest credits, deposits, and spends. But there's stuff in here, and let me turn on so we can see the private stuff. We actually see that even though the external API, which is what this is showing here in these methods, the internal structure is a bit more complex, and there's a lot of stuff about interest. Here, should, credit, interest, most recent credit interest for, some date stuff. All that stuff is making this account object more complex. So even just the amount of code that's dedicated to the interest stuff is already larger than I would prefer. So what we want to do is basically refactor out the interest credit functionality into its own class. Now, if we go back to our deposit test, if we run this test, we'd want to make sure that basically the deposit works, right? If we deposit $4.95, when we ask for the balance, it should be $4.95. However, if we run this test now, we will find that it fails. And the reason why is it credited 2 cents worth of interest, because it was calculating interest, as I mentioned before, for January 1st and for February 1st. So what we need to do is we need to say somehow, I want to isolate just the deposit functionality and of account without the interest stuff getting in the way, right? So that's something that I want to isolate out. Now, in my experience, what I see a lot of folks doing is like, okay, well, I'm going to mock out account and sort of suppress the crediting of interest, right? And basically turn it into a no-op. That might be okay if that's your only option because you don't own the account code and you have no access to it. But even there, I'd be putting a facade around it and doing some other things. But this is our code. This is it within our project, or if I was part of a team, this is within my team. And so what we want to do is we want to basically fix this test. Right? So if we run all of our unit tests, we'll find this is the only failure, and we want to fix this. Right? This should work if we basically isolated and put aside the interest credit stuff. So that means what we want to do is we want to go into account, and we want to pull out all the code that has to do with the interest crediting, and we want to put that into a separate class. Now, we also want to actually pull it out into a special kind of class, basically a strategy. And so the idea of a strategy is that it runs some algorithm and returns or some value basically against some other thing, right? That's the basic concept of a strategy. The reason why you want to do is you might want to swap out strategies. And that's something that we'll certainly look at later. But right now we want to swap out strategies so I can put in what's basically a no-op, don't do anything strategy. Because we might want to have more sophisticated strategies. For example, right now, the way we calculate interest is we look at what is the balance on the day of the month that we're calculating interest for. So if we're calculating interest for January 1st, we look at what is the balance for January 1st. Now, that's not necessarily fair because either you happen to deposit a bunch of money on that date, and so you get basically crediting of interest for that larger amount, even though it was only in there for a day, or you might have just pulled out a lot of money and basically lost the interest that you had, even though you had that balance for most of the month. And that's why typically most banks will do something like an average daily balance when they're calculating their interest. Here we were doing it to keep it simple, but that's something we might want to implement. And so what we want to do is we want to look at, okay, what is the part that is crediting the interest? And so what we want to do is, this is the method. So inside balance, remember the idea of balance is that it credits interest on the fly. And we want to continue to do that. So we basically want to, instead of calling this as a method inside of the account class, we want to be able to call it again something like interest strategy dot, right? Credit interest is needed. And a strategy often takes in one or more parameters to basically say, what am I crediting interest for, right? To what is this strategy applying to? And so that's another aspect of strategy, is that it generally doesn't have state by itself, right? The idea is either it is something that is passed in as needed. There may be some kind of configuration state, but the idea is you're applying, I want to calculate interest for this account. Or if you had, an e-commerce site and you had a discount strategy based on how much they purchased, whether they're a VIP customer, things like that, that stuff is passed in as needed. So this is where we want to get to. And this is a true refactoring in that none of our tests should have to change, right? Which means the API that we've built around account and our other classes should not have to change, because a true refactoring changes internal structure without changing the external behavior. So this is where we want to get, and so that means we're going to need to pull out basically everything connected to credit interest is needed. So we'll change this to public because this is going to move to another class. But what we want to do is first create an interface. So let's go ahead and we'll create a field here in account that is going to be our interest strategy. And then we'll go ahead and create an interface for it. And so this is in our domain. This has to do with sort of very fundamental domain stuff that we're doing that has nothing to do with infrastructure or technical aspects, things like that. So this belongs in our domain package. And the method that we're going to implement is credit interest. What was it? Credit interest as needed. And takes an account. So here we're basically saying, please credit interest to this, right? And so this refers to the account itself. And so it's basically saying, here interest strategy, here's account, please credit interest as necessary. Now you might be wondering why I'm passing in account and why I'm not just passing in, say, transactions or something else. The reason why is, remember that it does catch up interest credits, and so it needs to be able to add multiple, either add none or add multiple, basically 0, 1, or many interest credit transactions. Okay, so now that we have that, we're going to take this method, and even though there's automated refactorings, there's not really a good one for what we're trying to do. And even if there was, it would hide a bunch of the mechanics that is important to look at. So when I'm doing this mechanically, I basically say, okay, what's the first thing I want to pull out? This is what I want to pull out. And I want to pull it out to an implementation of an interest strategy. So I can go ahead and say implement interface. And so something about naming is that in my code and teams that I coach and so on, there are several things that I never want to see in the name of a class or an interface. One is impl. That tells you nothing about what kind of implementation it is. I see this in code over and over again where it's like, what are you implementing? Why did you have the interface in the first place? Some teams have some what I think are strange ways of thinking about interfaces, that like, oh, every class has to have an interface and you always talk to the interface. Like, no, that's not true. And what generally points to that as being a bad idea is if you can't come up with a good name for your concrete implementation. The other things that I don't want to see in names are things that have to do with the sort of technical language structure that it is. So for example, I don't want to see interest strategy or interest strategy interface. I don't need to see that. That doesn't help me understand what it is. I want to see things that are talking about what it is, not sort of underneath how it's instantiated or not instantiated. Another thing that I've also seen is abstract in the name. It's like, no, not abstract. If you have a hierarchy, then the fact that one of them is abstract is a technical issue. What I want to see are the names that are important. You know, this is an event which might be abstract. Then you have concrete specific events like, you know, interest credited, deposit credited, you know, those kinds of things. The fact that it's abstract is a technical aspect. I don't want to see those in names. So we're going to create an implementation of this, and this is the monthly interest strategy. And so we'll do that. We'll copy our implementation here. And now we'll see there's a bunch of things. Oh, this needs to take an account. We'll see a bunch of things that are now red because these are things we need to bring over from the account, right? We're refactoring things out of account, putting it into a new class. So let's go back to account. And we need a couple of things we do. We can actually look at well, sort of what is now considered unused. So first day of month after, credit interest, these are not used, this is not used. So we can basically take these, and this isn't used. So we can take all of these, go back here, paste them, and so now we see the stuff that's red. There's several different kinds of red. One is transactions, and we'll change that so that we get it from the account. One is calculate interest. So looks like we left that here. Yep, here's a calculate interest. So we can grab that, move it over to monthly interest strategy. We need to copy over this constant. So let's do that. And we'll put that here. Now, interest credit is basically a method against account, so we'll come back to that. Date time is only confused because it's not clear about transactions, and that's fine. And then clock, so it'll need an instance of clock. Now, if we go back to account here, we want to be able to have this as being final, and so we're going to have to sort of rejigger our constructors here. So we've got two constructors. Actually, before we do that, let's go back and finish everything else we can finish with strategy. So we've got transactions in red here and here, and what we want to do is access it from account. Now, this is where it can get a little bit of annoying because of the way that this credit interest is needed was written. This credit interest for made sort of two assumptions here. One is that it would have access to transactions, and the other one is that it'd be able to credit interest. Let's look and see where this is called. So this is called here. So instead of actually crediting the interest inside here, we could calculate the interest credit and credit it here because we have access to account here. So let's do that. And so interest credit is going to be right, so what this is doing is basically figuring out what is the balance through this credit date and then calculate the interest. And so all we need to do is return the interest. So let's do that. So we'll call this calculate interest for. And then this we can take out. And now we can just return this. And we'll fix this up in a minute. This returns an int. So this method is almost there. Then interest to credit is the return value of that. On account, we do interest credit, and this credit date and time is this. What did we do wrong? Oh, parameters are swapped. So it takes the date and time first, and then the interest amount. Okay. So what we've done is we've moved this around so that this now only needs the transactions to calculate things. So what we can do is we can say calculate interest for, and we can tack on another parameter, which is account.transactions. Let's go ahead and add that as the second parameter to this method. And so that's good. So what I'm trying to do here is I'm trying to avoid passing account all over the place, because I only want to pass around what is actually needed by each method down here. So this one, most recent interest credit date time, this one needs the transaction, so we can pass that in. So let's see where this is called from. So we can pass count transactions and then have it add that as the parameter. And then the last one is first date of now month. And so where is this used? This is used here. And so we have a decision here. We're getting the account. There's no current way to get the clock from the account. Normally that's something that's internal to the account. So what we can do is we can create a constructor for monthly interest strategy that either takes a clock or by default basically gets one from the system. Right? The one that gets a clock passed in, that would be used for testing. We don't have a test yet that needs that, so I'm just going to basically do private final clock, and make sure it equals clock dot system default zone. Right, which is actually the same thing as we have for account here. So that's basically so now we have monthly interest strategy, and it all compiles. If we go back now to account, this all is good in terms of compiling. So we can do a build just to make sure that we haven't missed anything. And we haven't changed any public interfaces, right? So what's left now is actually interest strategy here is null. And so if we tried to run our tests, we'd find probably a lot of null pointer exceptions, right? Good. It's always nice when tests fail for reasons that we expect. So what we want to do is now we can make this final, and then we have to deal with constructors. So what we want to do is create another constructor, and this one is going to be the one that takes our transaction repository, our clock, and now an interest strategy implementation. So let's fix up the indentation here. So this dot clock equals clock. This dot transaction repository equals transaction repository. And then this dot interest strategy equals interest strategy. And what we have is we have ones that there's some duplication here that maybe I might want to get rid of. So what we can do is change this one, and now we can have this one call the other one. So transaction repository gets passed along, clock gets passed along, and now we can instantiate the monthly interest strategy as the default. However, this is the one that we actually are sort of most concerned about. Not that this one's unimportant, but this is the one that's going to get called during our actual production application. So what we want to do is here we're setting the transactions to pull it in from the repository, which is important for production, the production version. we have some, so now basically we need to get an interest strategy here as well, so we can just directly assign it. Oops. And so maybe I'm not happy with some of the duplication here. I could clean this up, but then I'd have to create yet another constructor, one that takes the repository, the clock, this interest strategy, and the list of transactions. At this point, well, okay, so what's interesting here is from a domain standpoint, or really from a Spring standpoint, is this a component, right? Is this something that I want to be sort of put into to Spring's responsibility of tracking things? And my gut reaction is no. This is really a concern of account. It's not like this component is going to be injected into multiple places. It's really a strategy that belongs to an account, and account is deciding what it is. Later on, we might find that we want to do that, and then we would basically auto-wire interest strategy in here. So if we do a build, everything should still compile. If we run our tests, we won't have those null pointer exceptions anymore. We will have other errors though, because in our tests we let's see what's going on with these tests. So let's look at this one. Right, because now all these tests are well, all these shouldn't have broken. So let's look at this one. So here, this test is failing, which is interesting. Okay. So what's happening is the clock that we're setting on account is not getting passed down into the monthly interest strategy. So we basically need to have a constructor that takes the clock, which is what I meant to do and forgot about it. So we'll do that. So this can't be this. That was a mistake. Now we create a constructor that takes a clock. We'll refactor that. Yeah, there's no reason actually why we can't just have the clock always passed in. So now we probably have some places where maybe it doesn't compile, like an account when it creates it by itself. It needs to pass in the clock. So let's go to account. So IntelliJ, when it refactored, it did that for us. And same thing here. So now if we run the tests, now just that one test fails again. So that was good, right? But we expected those tests that failed because we missed something. From a test purpose, it wasn't inheriting the clock. All right, that's the Pomodoro timer. Let's see how close we are, what we need to do next. So we have now, we've fully factored out the interest strategy. We're back to the point where just this one test fails. So now this actually is a good time to take a quick Pomodoro break. And so when we come back, we'll look at what do we need to do with basically our test so that we can make this not credit interest when we don't want it to. So take a few minute break, and when we come back, we'll do that. All right, so before a quick break, we're back to the point where we now have this one test passing. Sorry, failing. All the other tests are passing. And so now what we want to do is we have a constructor for account that takes an interest strategy. So we want basically a no-op interest strategy, right? We want an interest strategy that does nothing. And what's nice, so we could do something like this. We could say uh, stub interest strategy. Whoops. So, or we could just say interest strategy, stub interest strategy equals new interest strategy, and basically put in this isn't anonymous because I gave it a name, put in an inner class implementation that just does nothing for this method. And then we can hand that into here. What's nice though is we're running at least Java 8, so we can turn this into a Lambda, because this strategy interface is basically a functional interface, because it has a single abstract method. It is a single method that can be overridden. So we can convert this into Lambda. In fact, IntelliJ says, hey, do you want to replace this with a Lambda? So let's go ahead and do that. So basically, it's stub interest strategy takes an account, but we do nothing with it, and that's it. So now if we run this, whenever account, which now delegates to the interest strategy, it'll do nothing. So this should make the test pass. Let's just run all the tests, make sure. And there we go. And so if we were to use this a lot, we might put this into a fake class, but it's so trivial that at most I would put it into a field that I'd use in other classes. I've mentioned this before, and in general, I don't like to refactor code as much when I'm in tests, because I find that I want as much sort of in the test itself, maybe with some the minimum necessary setup and teardown. But I kind of prefer to be a bit more verbose. It means that I may have to do a bit more work if I have to change something that affect multiple test methods. And this is something where I might pull this out. But it's like one line, although I can see that I'd probably want to use it in this test as well, so I might pull it out into a field. And that's okay, because it's named pretty well. Right? It's a stub interest strategy. In fact, I might even just be more specific, and it's a do nothing interest strategy. And actually, I wanted to do the assignment up here. And so we can run this these tests, and they pass. Let's fix up this test a little bit. So one of the things that I now have that we refactored last time was creating this test clock support. So I'm gonna let's turn this into a static import, and we can turn this into a static import. And so now we can create, and so maybe we want to, sure, why not? So let's go ahead and, oops, let's pull this into, really it's sort of a constant. Sure. And I guess technically this, make this private. And This is a static class, so we could basically do the same thing, and we'll rename it. So it's a do nothing interest strategy. And so now we can do the same thing here. So what do we call it? Just transaction repository. So let's call this fake. And so now we can create fixed clock on, we'll say 2019, March 2nd. And we'll now do the do nothing interest strategy. Let's fix up the... So just recall that passing in a clock to account tells account to pretend that this is always the current date and time. And so now, if we do this right now, basically the account was created in the future, and then we created some deposits. So let's just make sure if we don't have the do nothing interest strategy, this one should fail. And this one would be flaky because it depends on the current date and time of the system. So it has a deposit on February. Oh, actually, this should be fine because it's asking for today would be the 13th. That's when the deposits are. Actually, I would have expected it to calculate interest for that because it thinks today is March 2nd. Let's firm these up. Let's call these local date time as of midnight of 2019, February 13, and 2019 of February 13. And we'll run this one. Right, so that failed because it calculated the interest on March 1st. So now if we put back in our do nothing interest strategy, now this test will pass. Cool. And let's just make sure that all of our unit tests pass. And they do. What we probably want to do, let's see, it looks like we've got an extra semicolon here. And we can look at our interest credit test. Now, something we could look at doing is basically refactoring this interest credit test to directly interact with the monthly interest credit monthly interest strategy that we wrote. Because what this was doing was basically doing stuff to the account and then verifying that the account properly credited interest. But we could now directly test the monthly interest strategy. I'm not going to do that right now. What I do want to do is actually, so we've run all the unit tests. I actually want to run all the integration tests as well. Oh, right. So for this one, need to use the fake mock database for this. Actually, I'm wondering because now I remember that I have a to-do to fix some of this. So what was wrong with this? So this test takes much longer because it's using the database in addition to having Spring start up. So new account should have no transactions, that's fine. deposit to account should have a single transaction. What was wrong with this one? We got to redirect. What was wrong with this one? So, oh, right. Okay. So what happens is with this test, when the system starts up, it loads all the transactions from the database. And let's see. So what is wrong? It looks like this is very specific about order. So let's see here. Okay. So here, actually, this test is actually, now we can fix this one. This is a bit hard to read because there's just sort of so much data here. But basically, it was saying that it was this is the actual set of values that it got from running this. You'll notice there's a bunch of interest credits, which technically is what we want, but not for this test. And so this is an interesting situation because we're at an integration test level, and so the question is do we want to mock out? And this is why integration tests can be fairly brittle. We've added a feature. I think what makes more sense is instead of trying to account for all of these interest credits, let's sort of make the answer a little bit easier to work with. So this is basically saying, hey, there are all these transactions. I was expecting just this one transaction. I was not expecting basically all these interest credit transactions. So let's go make our test a bit easier to work with here. And we can do that by basically the problem are these dates, right? So this date is so far in the past that relative to the current date. And so we could set this to the current date. We would still get some flakiness though, because whenever this test runs on the first of the month, it will calculate a transaction for that first of the month. So and so the question is how much do we want to sort of mock out a part of the system when we're doing an integration test? So I think what I'm going to do is relax the test a bit. All that we really want to do is make sure that when we do a deposit via a post, that transaction is in there. If there are interest credit transactions, that actually is not a problem. If there are other transactions, that's okay. So we don't want to say contains exactly anymore. I think we just want to say contains. So let's now run these tests again. This will take a little while. So once this is running, we'll actually, once this is passing, we'll run the application, and there's something I want to try out that is actually functionality that's related to the interest credit stuff. Okay, so that passes, so we're all good there. Let's now run the application. And so we can go ahead and go here. Oops. Okay, so we have our application, the database is empty. We can go ahead and deposit some money, and that's fine. Let's go ahead and import. So one of the things that we supported was the ability to import some transactions. So let's go ahead and import all these. Now, one thing you'll notice is that I'm importing transactions that already have interest credit transactions. So paste that here, and we'll import. Now, take a second and look at this and see if you can figure out what's wrong. Oh, actually, there's nothing wrong. For a minute, I thought there was duplicate interest credits, but actually, uh, there are not. So that worked fine. Our current balance is that, and so let's go to account. There was something I wanted to look for. Oh, maybe it was in the CSV import. Thought there was something. Our adapter, web, CSV importer. Oh, okay, that's fine. Oh yeah, so there was a bug, and we'd fixed that, where when we were importing, we weren't marking the ones that were already interest credits as interest credits, so that meant that we were double crediting interest. But actually, that's all fixed, so that's not a problem. Okay, so let's go back to the other integration test. So these just test the, actually we can take these out. So let's run this, this test. This test takes a little bit to run because it's got to bring up Spring with all the database stuff, even though we're using an in-memory database. So this one is the test where we spent some money, and basically we got a whole bunch of interest credits that we sort of don't care about. So we need to do the same thing that we did before. Is uh, so here this is a different situation because our post does a deposit. The date is quite a bit in the past, um, but in a sense that doesn't matter because no matter what date we put here, there's a chance that interest will get credited, and so we can't guarantee that the balance is exactly what we deposited because interest gets credited, right? So, and look, the power of compounding interest, right? The first interest credit was 17 cents, and over the many years, it got up to 26 cents of interest credit. So basically what happened was is that the balance was offset. Um, oh, this is interesting. So, sorry, the, uh, the interest amounts are negative. Um, technically we're not supposed to let the account go negative, although right now we don't have anything that protects against that. So I do have a story for validation, which is somewhere around here. This is input validation, but actually I don't have a story for ensuring that the account never goes below 0, which I think is a fair thing to put in. So ensure account balance never goes below $0. So what happened was these interest credits are negative because we spent money, which caused the account to go negative, and then the interest credit was actually based on. So that's another thing, is like, should calculating interest on negative amounts, that should just always return 0. So even though we're going to need to put in validation to make sure the account never goes below 0, by itself as an individual thing, the interest calculation should basically just say if the balance is less than or equal to 0, no interest at all. All right, so let's create a failing test for that, and then we'll fix that. So let's go to this would be basically an interest credit test. And so we want a test that interest credit for account with 0 balance should calculate, should not credit any interest. So we'll just go ahead and make static imports for these, because then it's easier to read. So what we want to do is basically create a clock. And I'm going to go ahead and make these constants for this test class as well. And then I can replace these with fake transaction. I love the fact that I can do autocomplete in a replace box in IntelliJ. That's just so awesome. So replace, skip that, replace, 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 replace. Okay, all right, good. And let's make that private. And that's the problem with replace, is now I've got parentheses that I didn't remove when I did the replace. In the ultimate version of IntelliJ, I'm actually using the community edition for my presentations and live streams, just because I don't want to do things that assume you've paid for the ultimate edition. But the ultimate edition would have detected all those things that were duplicates, and that it would have seen those as duplicates and actually suggested, would you like to replace all of these with this one constant that you refactored out? Hey there, Borox 148. Yeah, web application development, getting into it is hard. I have done Angular stuff in the past. I'm not really a JavaScript guy, and so that was pretty hard for me as well. And I've been programming for a while, so all I can say is stick with it and start with really simple things, and just build up over time. Okay, so I refactored that out. I now can put this on one line, and I've got my clock, and I've got my initial deposit. So basically, I'll just change this amount. So just remember that our balances, oh, I know what I can do. Yeah, that makes it easier to read. I keep forgetting that actually Java, I think it was even Java 7, allows you to put underscores in your numbers. This is called a literal because I'm literally typing in this number here, so it's called a numeric literal. You can put underscores in anywhere you want, but you can use them so I can say this is really $500 because I'm storing amounts as pennies. So this is $500, and that makes it easier to read. Okay, so basically the idea here is made a deposit, and we want to say interest credit for account with 0 balance. So basically we don't want to deposit at all. And Pomodoro time, so I'll take a break in just a minute. We don't want to deposit at all. We do want to say that, well, we're going to need something to trigger interest credits, because a new account, the current way that the monthly interest credit stuff works is it looks to see what is the first transaction on that account. It considers that sort of the account opening date, and then calculates interest from there. So if we don't have any transactions, it's not going to calculate interest at all because it considers the account sort of not really there. So I actually do want to deposit, but then we kind of want to immediately withdraw it. So we end up with a 0 balance. So account.spend, and we'll put it on the same date and time, and we'll spend $500 and spend all the monies, as my son calls it sometimes. So now we should have a 0 balance. We could put in a temporary assert that that's true. Assert that account.balance. Actually, we're going to assert that it's 0 anyway. So assert that account.balance is 0. Now this is sort of a weird edge case, because even if it actually does calculate calculate interest, it, like, even if that's triggered, it would still calculate as 0, because 0 times anything is going to be 0, but we'll put this here. We're really interested in the negative one, but this provides our boundary condition, and whenever you're thinking about testing, you want to test the boundary condition. What is the boundary? Typically it's 0, but sometimes it's like a little bit off of the boundary. And we want to test sort of both sides of the boundaries. So we've already been testing a bunch of the sort of more happier case scenarios of positive balances. We actually haven't tested the boundary or anything less, so we're gonna do that here. So this was interest credit for, so this should work. We'll run this. Okay, and now we'll basically take the guts of this, create another test. Interest credit for account with negative balance should not credit any interest. So we'll set this up where basically we don't do any deposit. We'll just spend money I don't have. We expect the balance to be equal to negative 500, and that's in pennies, right? We opened up the account, we spent money, we currently don't have any validation or protection around going negative, and you may be okay with your kids basically spending into the negative. I'm not, but we'll fix that later. Now this test I expect to fail, because it's going to calculate interest on the negative 500. And indeed it does. And you see this over here where we're getting 310 cents more negative. In a sense, we're actually charging interest because we're pushing deeper into the negative. But yeah, no, I'm not willing to have my son give him credit so that he can go past his actual savings. This is a virtual savings account, and if he has no money, he can't spend it. Okay, so we need to fix this. Let's run all the unit tests because I want to make sure that this is the only one that's failing. And it is. Good. Okay. Oh, we were on a Pomodoro break. Let me take a quick break. When we come back, we'll make this test pass. So we saw that this test pass, right, is where basically we're charging interest. We don't want to do that. So let's go ahead and fix that. So we'll go into our monthly interest strategy. Now, there are a couple of options. The question is we can sort of prevent that from happening in our strategy here, but we could also prevent it from happening in our account by basically saying only do this if the balance is currently greater than 0, right? Don't even call the strategy if the balance is 0 or less. And there's no right answer because this is really a business decision, right? A customer decision. What as the business, right? Thinking about, right? This is my business, and I have certain policies. Do I think that I will have an interest credit strategy that um, would uh, would need to be calculated even though the current balance is 0? Right now, that's the case where it doesn't matter because the way as I mentioned earlier, the way the current interest credit calculation does, it calculates it on the day that it's going to credit the interest, right, the first of the month. It looks at the balance on the first of the month. But you may have had balance previously, and just today it happens to be 0. You should still get interest credited for the previous time. But our current strategy doesn't take that into account. So given that in mind, to me, it makes more sense to, look, delegate it completely to the interest credit strategy. Uh, and if it decides that it shouldn't credit any interest, then that's fine. The account really should, I think, even thinking about it more, it's like the account's really responsible for making sure its integrity is okay. Um, if I don't want to allow it to go less than 0, then I need to put some protections in the spend method. Um, uh, Sorry, I just noticed that this should credit interest method is not used. Um, I think actually, sorry, I just realized this method isn't used uh, mainly because I think this is a holdover from the previous way I was, like 3 episodes back, the way I was calculating it. So I'm going to go delete this. And that's another reason why factoring stuff out into smaller classes means you're more likely to see stuff that you didn't see before. Either names that you didn't see before or objects that are screaming to be put into their own thing. Um, so good, we deleted code. I love deleting code. Deleting code is awesome. Okay, so we were going to say that account is always going to call the interest strategy and let it decide how it should credit interest or not. So let's go ahead and go to our monthly interest strategy. And so what we should be really doing here is only crediting interest if there is if the balance is basically greater than 0. Now, what's interesting is should we create a transaction that basically says 0 interest? So what's nice about doing that is, let's say the balance is sort of 0 for a while. If we never sort of save those transactions where we're crediting basically 0 interest, we will continually calculate those, even though we've seen them already, right? Because again, the way the algorithm works is on the fly, it looks to see what was the last interest credit transaction, and then calculate and fill in missing interest credit transactions since there. But if we never write the $0 ones, then we're constantly recalculating stuff that we actually don't have to. So, and this is basically a business decision. I am going to decide from a business standpoint that the 0 penny, right, no interest credit transaction should be created. So all I have to do is make sure that when we do calculate interest for, it returns 0 if the account is it has a negative balance. So our calculate interest basically if current balance is less than or equal to 0, return 0. And so what we're saying here is basically if the balance is not greater than 0, we just return 0 for the interest. Now you could say, well, we could just say less than 0 and let this calculate out to 0, but we'll leave it at that. I'm almost tempted to pull this out just into a Boolean, but I think it's clear enough right now that it wouldn't be hard to say, oh, if current balance is less than 0, just return 0. So I'm going to leave it at this. I'm not going to do any refactoring here. All right, so let's go back to our test. So now this test should pass, because now there's the rule that, but there's an additional thing that we want to check is not just that the balance is this, but that there also was multiple 0 interest credit. But I'm going to put that in a separate test because this one's just checking the balance. It's really a separate sort of decision. It's orthogonal. It's not completely related to the amount that I want $0 interest credit transaction. So let's run this test. We'll run all the unit tests. In general, I like to run all my unit tests because they run super fast. There's really no difference between running one unit test and running my 36 unit test, right? They still take under a second to run. This is complaining about the fact that I ran the application in debug mode. Let's just close that. And the test passed. Cool. So now let's write one more test that says basically negative balance should result in 0 amount interest credit transaction. Right, so now we're asserting sort of the other side of what we were talking about before, which is if the balance is not doesn't deserve any credit, we're still getting zero penny. We're still getting interest transactions that are just 0 pennies. So let's set up our clock. Let's do. Oh, that's kind of funny. The dates were. This is what happens when I copy and paste. Is that actually my clock dates are wrong? I'm wondering if it's even meaningful to name them. You know what? I'm going to rename these because actually I realize reading these, it's not this name where I'm tacking on the date is actually not helpful, because if I want to see what the original date was, I can just go and look at this line. So I'm going to rename this to just clock, or yeah, clock. And I'll rename this to also be just clock, and this one to also be clock, and this one, and now this one. Okay, so let's say it's January 28th. Let's say today is actually February 2nd. We'll go ahead and create the account and we'll make it negative. We'll make it negative as of January 30th, right? So basically we expect there to be a single interest credit transaction, but we expect that transaction, its amount to be 0. So now we can say we don't care about the balance, we just want to trigger it. Calculation. And so now we assert that when we ask for the account's, oops, transactions, we expect it to contain well, really what we'd like to do is we want to filter out, I'm wondering if we want to go streams here. We could say contains exactly and put the deposit transaction and the interest credit transaction, but that makes the assertion a bit harder to see. Yeah, let's do that. So we'll say account.transactions stream, and we will filter such that the transaction is interest credit. Oh yeah, we can actually just use that. So now we're just getting interest credit transactions. Whoops, that parenthesis is wrong. Arg. No, the parenthesis is right. Okay. So now we filter out, so we're only looking at the interest credit transactions, and we want to make sure that that one is basically has an amount of 0. So we will map it to basically transaction signed amount. Amount or signed amount actually doesn't matter. In this case, we just want it to be 0. So now we get, there we go. What's nice about IntelliJ, and this is something that I've come to really appreciate the more I do streams, is that you can see sort of the processing of the transactions. So a mutable set is what we get from the transactions. Then we get basically, now we're streaming the transactions. We're filtering it, so we're getting still a stream of transactions. Now we've mapped it to ints, and so now we're just getting a stream of integers. We could just sum this up. And why isn't it like that? We mapped it to integer. What am I not doing right? I can reduce it, but I want to just sum it. Why doesn't it like that? I've mapped it to integers. Map to int. Do I need to do a map to int? Now sum. Okay. Yeah, so because I want to actually sum over all the integers, I was getting a stream of integer objects, and I'd have to write my own reduce function, which is kind of ridiculous. What I really want to do is map it to primitives. And now I can save this. So introduce local variable, and now I can assert that sum is 0. Because really, actually, I don't care how many transactions I have. In fact, I might want to push it a little more and say today is March 2nd, and so the deposit is on January 30th. So I expect the February 1st and March 1st transactions. So I could do that. I could hold this in a stream and assert not just that the total sum is 0, but actually that there are only 2 of them. But I feel like actually I kind of should do that because I could basically end up summing over none. Yeah, so let's do that. Okay, so let me extract from here this part of the stream. Extract this to the interest credit transactions. And so now I can calculate int count equals interest credit transactions dot count. Required int found long count returns a long. Sure, fine. Actually, let's just do this. I'll just assert directly on that. So assert that. I don't need to store it in a variable. I'll just correctly do that. Hey there, Alex. Thank you for the welcome back. So we're going to assert that the count, we expect 2 transactions, so it's equal to 2. And that we expect then the sum over both of those transactions, the sum to be 0. So let's run all our tests. And this one, stream has already been operated upon or closed. Oh yeah, that's right. I can't do that. Well, let's see. Right, because count is a terminal operation, so it will close the stream. I could just assert that there are just 3 of them, right? The deposit plus the 2, but I really want to sort of assert that there are 2 of those. All right, so let's do this. Let's inline. It'll make this code a bit longer than I'd like, but I forget, does AssertJ have support for streams? Is equal count. Oh, that's interesting. So it sees it basically as a bunch of transactions. I can say has size. Will that work? So basically we're getting transactions, turning it into a stream, filtering on that it's an interest credit, that there should be 2 interest credit transactions. Let's try that. And that passes. I'm uncomfortable with it passing. I actually want it to fail. Let's comment this out, and it should fail. Then the part that should fail is not that there should be 2 transactions, but it should fail because, so this one failed, right? This one should also fail because the amount was not 0, which is good. I guess I technically don't need to do this part because this is actually already covered by this, right? So basically I changed something, both these tests failed. If I now undo that change to basically re-implement and refix the problem, both tests will pass. This one is checking the amount, right? The interest credit fee, basically this is saying that the amount shouldn't change, right? I spent $500, so my balance should be negative 500. And so then therefore this is sort of redundant because I'm already checking that my interest credit transactions sum up to 0. So this is redundant. This test is really that it should result in 0 amount interest credit transactions. That's all that matters here. And so I don't want to have that redundancy because that doesn't give me any more information. Let's make sure it still fails. So now actually this one should pass, and that's fine, and this one fails. Good. And that's another thing you want out of your unit tests. You don't want noise, and you don't want lots of tests to fail for the same reason. You want each one to be sort of, from a diagnostic standpoint, as precise as possible. Okay, so we fix that. And boom. Because if we had fixed it differently, so for example, if we had said we're only going to, so if we wrap this in a no, that's not what I wanted to do. Darn it. That's what I wanted to do. If we wrapped it's in an if block, and if we said if interest to credit is greater than 0, basically only add the interest credit transaction if the amount is greater than 0, that would also work, right? But we'd see that, right, and if we run our tests, we'll see that now the one that's failing is just that there are no transactions, but our sum is still working, right? So we're basically have one test failing based on kind of our business decision, right? The one that where if it was negative, we didn't get any interest, this one passes, right? So from a sort of higher level standpoint, we're at least not changing the balance based on the fact that the balance, we're not basically adding any interest. Uh, the way we currently have it, though, we're not actually creating any transactions at all. But we decided that from a business standpoint, I want $0 interest credits. So now we'll run all our tests. And they all pass. And so this all started because we were running this integration test where we had spent money to reduce the amount, and we got some weird thing going on here. So let's go ahead and run these tests, and then we'll see what it looks like actually from the UI. And again, these tests take a little bit longer because they're not just bringing up the application, but also bringing up the database and connecting all that stuff. Okay, so this one succeeds because all the interest credit transactions are zero. This one still fails because we basically have all these interest credit transactions that we don't really want. At least we don't want them from the point of view of this test. So, and again, this is where testing at this level makes it harder. We could, now there's things we can do, right? So from Spring, we could create a configuration that injects, that actually injects a fake or stub monthly interest credit strategy. Actually, this test is passing. It's this test is failing. That's a little bit more than I want to do right now, considering this is just an integration test. So what that would require, so remember when I first pulled out the interest strategy into a separate class, I said at that point I didn't want to make it a component and Spring was aware of because I didn't need it to do dependency injection. But from this integration test standpoint, I kind of need it. So what I can do is I can basically just say that the balance is not zero, and because I can't even say what amount it's going to be because this is all I don't have a fake clock in scope, right? Because I'm running as my integration test here is as close to the real thing in terms of all the domain logic is real. So the clock is real, the interest strategy is real. The only thing that's sort of not real is that it's using the in-memory H2 database, but otherwise everything else is pretty much real. And so I can't really assert what this is. Because yes, today it's going to be, what is it? If I look at the balance. So today it is $20.16. But that's because today is February 13th. And so if this was run on March 13th, this amount would be higher because I'd get another 4 cents of interest. So there's really no way other than actually doing the calculations, which is kind of ridiculous. Why would I do that? I already have tests for that the calculations are correct. So again, it's sort of like, what is this? What do I want out of this integration test? I simply want that the deposit worked, and that actually all I care about is that this transaction exists. When it starts, we've already established, have we established that this transaction? I'm wondering what purpose now those tests are actually giving us. Because this is really the better test. I'm not sure that I need this level of the integration test, right? Because these two integration tests are actually fairly similar. But they're sort of only testing at the higher level, right? So I'm not sort of going behind the scenes to look at anything. I'm looking at, I'm doing basically an HTTP post, and then I'm doing HTTP GET. So the actual calculations aren't very useful. In fact, I don't really care. I just want to make sure that when I deposit, that I basically get back to the page. That's all I care at this level. I actually don't care about the balance because I have a test for that, and I have all my unit tests to test that. So, um, so we can just say um, and expect status is okay. By the way, this is the stuff I hate about these kinds of matchers is the IDE can't help me complete these as well as something else. I could leave this, but even so, it's sort of giving me this sense that what if I do start charging interest on this? Then I have to change this test. Yeah, I'm not happy with these integration tests. I think they're more really kind of high level checks that I haven't broken anything on my routing or on the template itself. All right, so let's run all the tests. They should all test. They should all test. They should all pass now. While those run, I'm going to take a quick break, and when we come back, we'll look to see what's next. For the break, we found that maybe our integration tests here could use a little bit of attention, but otherwise everything passed. I have one test that's being ignored. Actually, I don't need to ignore that anymore. So this one and this one. So all our tests pass. If we go back to our story, refactor out interest crediting strategy, so we can call this done. Yay! Yes, I still need a celebration sound effect, but we'll call this done. So let's go ahead and commit that. So this is episode 12, refactor interest credit calculation into interest strategy. Fixed up integration tests. And that's it. So we'll commit that, and we'll push it up. So, all right, so that's done. I'm going to move this up. This is like my fourth or fifth episode of dealing with interest credit, and I still have a bunch more. This is perhaps a little bit of overkill for what I want, but there's actually still some stuff that I want to do with interest rate with the interest rates. So, for example, what if the rate changes over time, and so you now have point in time issues, right? So, as the Fed raises the interest rate, accounts your bank changes your interest rate, but they don't go do it retroactively. So not only would we figure out what dates are we calculating the interest rate, but what interest rate do we use at that point? And so there's sort of time and effect, interesting things going on there. I definitely do want to go to this use average daily balance for the interest rate calculation. So I'm going to actually move this up. There's some auditing stuff that I might want to do, such as what was the balance when I actually credited the interest rate? Like, what if we got something wrong? But I'm not sure about that, so I'm going to push that down a bit. There's some operational stuff around database migration that I'm going to want to get in fairly soon. So I'm going to sort of move this up to there. I don't have any specific database schema changes in mind, but I want to. The nice thing about sort of Flyway and the similar database migration things is the sooner you get those in to establish a baseline, the easier it is to later migrate. Let's see, persistence and integration task cleanup. I think I'm done with that. This task, ensure the interest rate is fixed. We actually fixed that by using the strategy, so that's done. I'm going to do this offline. I'm not sure if there's anything left here, but I'll leave that there. So the question is I've allocated about 15 minutes left for today's stream. I wanted to do this one keeps getting pushed down, the request balance via SMS. So I'm not sure we'll be able to implement this, but we might be able to at least get this one started. So let's put this into doing, and let's at least get this a little bit moving. And in tomorrow's stream, we'll definitely start out with that. So my plan was to use Twilio because they are the king of SMS and other kinds of things. It's been a very long time since I've used Twilio. So we want Twilio. And yes, I actually own some of their stock because I think they're that good. So let's see. We want docs and tools. We want quick start. Because what we want is we want the ability, right? So this story is about my son's phone is an Android phone. But more importantly, he doesn't have data, which means he needs to be able to, if he wants to check his balance, he needs to be able to send an SMS text message because that's about all he has. And so we want a programmable SMS. We'd like it in Java. I've always been impressed by Twilio's docs, API docs. I think they've always been really good. So let's see. So sign up for Twilio and get your first SMS-enabled Twilio phone number. I'm already signed up. So let me log in. So let me switch to secret mode. So let's log in. I think I still have that account. Yes, apparently I still have that account. That's kind of funny. Apparently my account was suspended because I have a negative 11-cent balance, so I owe them money. Check my usage. I have no usage. Authorize apps. All right, well, I'll deal with the billing stuff later. So let's go back now to, let's see, go back to quick start. Okay, cool. So now you can see stuff again. Okay. So what we want is, so we're signed up. I'm signed up. Let's see. So set up your development environment to send and receive messages, send your first SMS. So let's see how this is done. So pretty much this. So this is the SMS sender. So we're going to have to get the Java helper library. So let's do that. So set up your Java environment. Jump to the next step. And so we want to get the, I don't want to install this, I just want, okay, so here's our dependency. I forget, am I using Maven or Gradle? I'm using Maven, okay. So we'll go to our POM. And we'll add that as a dependency. Oops, copy the wrong thing. There we go. And we'll let IntelliJ go and find it. It's indexing down here, and it's there. Cool. All right. So we did that. I don't need anything else. We can do a test. One thing I'll have to figure out is my auth token is not something that I want to push in anywhere. I'll have to make that as an environment variable to pick that up as a property. But I'll set that up before next time. Okay, so let's go back. So download, send an outbound SMS message. So the way we do that is basically this code. I'll have to figure out what my number is, because I thought I bought a number, but it might have expired because I haven't used it for a while. And we've set up that, we've done that. So we create a message, and then we create, and this is the content of the message, and I guess that would be it. So we'll have to create and replace these placeholders with my stuff. Again, I'll get these offline. And right, as it says, you should not hard code them, and this will not go into the repository. I will keep them locally. So that's actually something we'll do as a task. Let me add that as a task as part of this. Is we'll need to add environment variables for Twilio credentials. So that'll be part of that thing. What else? So that's our API. So the from phone number, good old E164. So I'm actually working with a client where phone numbers is a core thing of what they do. So E164 is basically a standard way of formatting numbers. So I'm scarily familiar with that. We'll replace the to number. So there's a question of how does my son tell the system what his phone number is? So I'll initially hard code that, but one of the next things that we want to do is sort of simple authentication. So we might need to do that pretty quickly afterwards. So to set up some kind of account profile, which would be things like, besides username, password, which I'm going to totally delegate to something like Okta or Auth0. I'm not going to do that myself. But there's sort of the role. So are they the kid who only has access to checking the balance and maybe spending? Certainly not depositing, right? The deposit, that is certainly the sole authority of the parent. So there are two roles. There's kid and parent. Now, there's a connection between those two, right? Because they share the same account. So basically an account is going to have two, what are we going to call them? Not owners, but I need to figure out a good name for that. But anyway, so things like their phone number that they want to get text messages on would be in there, would be associated with the individual profile. So I can't call it account, right? Because when you log in, you're not logging in as an account. Uh, you're logging in basically as uh, user. I know some people don't like that name. I don't get hung up on it. It's like, look, I use this thing, so I'm a user. I don't have a problem with that. So there's some things we'll have to figure out there. But for now, this story would be sufficient to using a hard-coded phone number, which I just realized we'll have to go into the environment variable because it's not like I want to check in his phone number into my GitHub repo. So add environment. And actually, for testing purposes, I don't want to use his phone number. I want to use my phone number. So add environment variable envar for SMS phone number. What else are we going to need? We're going to need, so I got the account credential for Twilio, got the SMS phone number. That's kind of all I think we'll need. We'll basically use something like this code. And what we'll see is we're going to create a facade, right? Because we don't want to tightly couple. Again, this is going to be going all the way back to the architecture that we're using here. We're using the hexagonal architecture. Usually have my PowerPoint up, but while I wait for that to load. So the idea is we're not going to directly couple our account balance code with Twilio. We want to create a nice facade that basically is send balance, and that way it's testable. We're not reliant on Twilio per se. We could use something else. It may not even be SMS, right? SMS is just one implementation of basically an account balance notifier. So PowerPoint, since this is our right. So this is our, this is an example of the architecture, right? So all of our account and transaction and interest strategy is in this center hexagon, right? It's pure domain. It has nothing to do with any kind of technical infrastructure. So far we've added a web adapter that is our MVC for displaying that stuff, and we've done persistence, right? But our repository, basically our account is internal here. We've hooked it up to Postgres when we deployed it to Heroku, and so that's a concrete technical infrastructure implementation, but it's separate from the domain. And so then next we'll be adding another adapter. So if we go back to our code and we look at our package structure, right? So this JPA here, this is basically this persistent storage implementation in our adapter package. And here's our web package that has all the stuff that deals with this adapter. Something that I'm going to do, actually, let me add a task to remind myself. Even though it's a bit of overkill for this small project, it's actually nice to see it as separate sub-projects, because it really draws the line very clearly between our core domain and our infrastructure things. I should be able to have multiple projects, one representing the core domain, and I should be able to build it and compile it and use it. And then the other ones will depend on that that thing. So that's more of a task. That is create multiple sub-projects. This is sometimes called sub-modules, but I think sub-projects is a better term because modules, sometimes people get that confused with Git. This is not Git sub-modules, although you could use it, but it's not Git. So in Maven for the adapter packages. Okay. What else? Right, so the idea is in our domain's not going to be really that involved. because so the question is when the so the triggering for sending the balance through the SMS, um, there are basically two scenarios. One is an SMS message comes in to request it. The other is, and probably the more interesting one to start out with, is the balance changes, and so we want to send out a message saying, hey, your balance has changed. And that directly matches this kind of external notification, right? It's an outward notification, right? Something happened in the domain, and we want to notify somebody, and versus sort of the initiated coming in through the adapter, something happened and sending a response. This is really initiated internally due to something else happening uh, and sending out an external notification. So I think that's the way we'll go in terms of what we'll implement. So let's make that a bit more. So this is the request balance via SMS. Um, uh, well, you know what? From a test, from sort of a playing around with, we'll do that first, but then we'll do this notify a balance change via SMS, and then we'll have other ways of notifying about balance change. So maybe we'll do this one first because it's sort of the easiest to see. What else? So once we have that, we actually want to receive and reply to an inbound SMS message because that's actually what we want to do. That's send an outbound message. I want to receive. So Twilio is going to send an HTTP request to a server that we control. So this is going to be let's see. So when Twilio sends your application a request, it expects a response in a special TWIML XML format. So this we're going to be implementing a webhook, and so what's going to be interesting there is actually there's a little bit more work because when we're testing it locally, Twilio has to be able to call our server, and so there's a tool. ngrok is one of them. Ngrok is basically can expose a locally running server to basically the internet, and we'll use that just to test and make sure things work, make sure Twilio is calling our thing, and that way, again, when we deploy it, it'll actually when we deploy it on Heroku, it actually will be on the public internet, and so we'll make sure that Twilio can contact it there. So the question will come up when we start working on this is how do we configure what the webhook is like? So where does Twilio, what basically URL does Twilio hit in order to send the message saying here's your SMS message? So we'll look at that next time. This is sample code for sending an SMS. We want responding to an incoming one. Yeah, so this is what it's going to look like. Basically, we'll configure something like /SMS with this is what we expect, and then we send a response. And so there's some stuff here, basically this messaging response that we'll use to send and receive. When we build this, we will start with basically a fake implementation. We'll have a nice facade, and then we'll plug in the implementation of the Twilio one, and we'll move on from there. So that's it for today. If you have any questions or things you want me to discuss in future episodes, Twitter is one of the best ways to get me. Twitter, I'm JitterTed on Twitter. You can also go to the GitHub repo, and you can find all that information if you go to my website, Ted M. Young, and you look at this blog post, KidBank. It has basically all of the information about this entire stream of videos. And you can see the GitHub repo here. The YouTube channel, I'm a little bit behind on editing stuff because I was away, but I'm going to be getting more of that out there to sort of catch up in the next couple of days. And the link to the public Trello board. So hit me up on Twitter. You can also file an issue on GitHub if you want to even propose a pull request, go for it. And that's it. All right, and so I will see you tomorrow at 11. Have a great rest of your day.